Hello and welcome to the Slumber Lab. I'm so glad you're here tonight. Whether you're already tucked beneath your covers, settling into your favorite chair, or simply letting your thoughts drift as the day winds down, this space is made for you. Tonight, we begin a gentle journey into one of the most extraordinary phenomena in our universe. A cosmic dance so profound, so beautiful, that it reshapes the very fabric of space and time itself. We're going to explore what happens when two of the most mysterious objects in existence find each other across the vast darkness of space, spiral together in an ancient waltz, and ultimately become one. But we won't rush there. We'll take our time, letting our thoughts move like distant galaxies, slowly orbiting around wonder. We'll start, as all cosmic stories do, with gravity. That soft, invisible hand that guides everything from the apple falling from a tree to the largest structures in the universe. And just a gentle note before we drift deeper into tonight's exploration. I've crafted this to be a deeply calming experience, a place where science meets serenity. But fair warning, sometimes the universe is just a bit too fascinating. If you find yourself staying awake with curiosity about colliding black holes and gravitational waves, that's perfectly fine too. At least you'll drift off a little wiser about the cosmos. If you're enjoying this peaceful corner of the universe already, I'd be so grateful if you gave this episode a gentle like and perhaps subscribed for more restful science. It helps other sleepy minds find their way to these cosmic lullabies. And if you're listening from somewhere special tonight, let me know in the comments. I love watching our bedtime constellation slowly light up, one peaceful stargazer at a time. As always, this narration is for relaxation and educational purposes only. It's not a substitute for medical advice or sleep therapy. It's simply a soft companion for the night, a guide through the gentle mysteries of our universe. Now, take a breath. Feel the weight of your body settling, that weight you feel, that gentle pull downward. That is gravity at work, the same force that will guide our story tonight. Let's begin our journey into the cosmic deep, where two impossibly dense objects are about to teach us something beautiful about the nature of existence itself. Gravity is the universe's most patient storyteller. It whispers rather than shouts, pulls rather than pushes, and shapes rather than breaks. Every object with mass, from the smallest grain of sand to the most massive star, reaches out through space with invisible threads, gently tugging on everything around it. You feel this pull right now as you rest. The earth beneath you isn't holding you down with force or aggression. It's simply curving the space around you, creating a gentle well in the fabric of reality that your body naturally follows. This is Einstein's gift to our understanding, the realization that gravity isn't really a force at all, but rather the shape of space itself. Imagine, if you will, a vast cosmic mattress stretched infinitely in all directions. Now picture placing a bowling ball in the center. The mattress dips and curves around the ball's weight. If you roll a marble nearby, it doesn't move toward the bowling ball because of some mysterious attraction. It simply follows the curved surface that the bowling ball has created. This is how our universe works. Massive objects like stars and planets bend the fabric of spacetime around them, creating curves and wells that guide the motion of everything nearby. The Earth orbits the Sun, not because it's being pulled by an invisible rope, but because it's following the straightest possible path through the curved spacetime that the Sun's mass creates. But tonight, we're not just talking about planets and stars. We're venturing into regions where this cosmic fabric becomes so deeply curved, so profoundly warped, that even light itself cannot escape. We're talking about black holes. A black hole isn't really a hole at all. It's a region of space-time where matter has become so incredibly dense that it creates a well so deep, a curve so steep that nothing can climb back out. Not light, not matter, not even information. Once something crosses that invisible boundary, called the event horizon, it's committed to a one-way journey toward the center. Think of it like a cosmic waterfall. Far upstream, a leaf floating on the river can still turn around, can still paddle against the current, and escape. But once it reaches the edge of the waterfall, once it crosses that point of no return, there's only one direction left to go: down. But here's where our story becomes truly extraordinary. Black holes, despite being among the most solitary objects in the universe, don't always remain alone. Sometimes, across the vast emptiness of space, two of these cosmic giants find each other. Picture this. Somewhere in a distant galaxy, two massive stars have lived out their entire lives as binary companions, orbiting each other in a gravitational dance that has lasted millions of years. These stellar partners have grown old together, burned through their nuclear fuel together, and now, at the end of their cosmic journey, they collapse together. When a star more than 20 times the mass of our Sun reaches the end of its life, it doesn't fade gently like a dying ember. Instead, it collapses catastrophically in less than a second, creating a black hole. Now imagine this happening not to one star, but to both members of a binary pair, perhaps separated by just a few million years. What remains are two black holes, invisible against the darkness of space, but still locked in their ancient orbital dance. They circle each other like cosmic partners in an eternal waltz, their gravitational embrace keeping them bound across the void. But here's the beautiful, inevitable truth. This dance cannot last forever. As these two black holes orbit each other, something remarkable happens. They begin to lose energy, not through friction or heat, but through something far more subtle and profound. They create ripples in the very fabric of space-time itself, sending out waves of gravitational energy that travel at the speed of light across the universe. These gravitational waves are like the wake behind a boat, but instead of disturbing water, they disturb space and time. Every orbit sends out these cosmic ripples, and each wave carries away a tiny amount of energy from the system. It's an incredibly small amount at first, so small that it would take longer than the age of the universe for this energy loss to have any noticeable effect. But as the black holes slowly spiral inward, drawn closer by their mutual gravity, something extraordinary begins to accelerate. The closer they get, the faster they orbit. The faster they orbit, the stronger the gravitational waves become. And the stronger the waves, the more energy they carry away. It's a cosmic feedback loop that builds upon itself. What starts as an almost imperceptibly slow spiral becomes faster and faster, like water circling a drain. The black holes draw closer together, their orbital dance becoming more and more frenzied, until they're whipping around each other hundreds of times per second. In those final moments before collision, these two objects, each with the mass of dozens of suns compressed into a region smaller than a city, are moving at a significant fraction of the speed of light. The gravitational waves they produce become so powerful that they actually carry away mass energy equivalent to several suns, all in the space of a few seconds. And then, in an instant that reshapes local space-time itself, the two black holes touch. Their event horizons merge. The violent orbital dance suddenly stops, replaced by a single, larger black hole that settles into peaceful rotation. But we're getting ahead of ourselves. Before we witness this cosmic collision, we need to understand something profound about the nature of space-time itself and how two of the most extreme objects in the universe can actually find each other across the vast emptiness of space. The story of how black holes meet is really a story about time. Not time as we experience it, ticking away second by second on our clocks, but cosmic time, measured in millions and billions of years. It's a story that unfolds on scales so vast that entire civilizations could rise and fall in what amounts to a single moment in the life of a binary black hole system. When we look up at the night sky, we're seeing the universe as it was, not as it is. The light from the nearest star beyond our sun took over 4 years to reach us. The light from distant galaxies has been traveling for billions of years, carrying images of a cosmos that may no longer exist in the same form. Black hole mergers happen on these cosmic timescales. The gravitational waves we detect today from colliding black holes began their journey through space when the universe was young, when the first galaxies were just beginning to form, when the cosmic dark ages were finally ending and stars began to light up the void. But here's what makes this story so remarkable. Until very recently, we had no way to witness these cosmic collisions. Black holes don't emit light. They don't send out radio signals or X-rays on their own. They are, by definition, invisible against the darkness of space. The only way we knew they existed was by watching how other objects behaved around them. We could see stars orbiting something massive and invisible. We could watch gas and dust spiraling into accretion disks that glowed with incredible heat as they approached the event horizon. But the black holes themselves remained hidden, like cosmic ghosts whose presence could only be inferred. That changed on September 14th, 2015, when humanity achieved something extraordinary. For the first time in our species' history, we heard the universe speaking to us in a completely new language. Not through light or radio waves or any form of electromagnetic radiation, but through the fabric of spacetime itself. 2 massive detectors, each with arms stretching 4 kilometers in opposite directions, felt the universe itself expand and contract by less than 1/10,000th the width of a proton. It was the faintest whisper imaginable, a tremor in reality so subtle that it took the most sensitive instruments ever built to detect it. But what that whisper told us was extraordinary. Somewhere in the distant universe, more than 1 billion light years away, 2 black holes had just completed their billion-year dance and merged into one. The gravitational waves from that collision, traveling at the speed of light, had crossed the entire observable universe to reach us. They passed through galaxies and stars, through planets and moons, through the Earth itself, and finally through the incredibly sensitive laser interferometers that we had built precisely to listen for such cosmic whispers. In that moment, we didn't just detect gravitational waves for the first time. We opened an entirely new window into the universe. We gained the ability to witness events that would otherwise remain forever hidden from us. We learned to hear the music of the spheres, the rhythm of spacetime itself as it vibrates with the echoes of cosmic collisions. But what exactly happens when 2 black holes merge? How do these invisible cosmic giants find each other across the vast emptiness of space? And what can their collision teach us about the fundamental nature of reality itself? The answer lies in understanding something profound about the relationship between matter, energy, space, and time. When 2 black holes spiral together and merge, they don't just combine their masses like 2 drops of water joining together. Something far more extraordinary occurs. In those final seconds before collision, as the black holes whip around each other at incredible speeds, they convert a portion of their mass directly into gravitational wave energy. It's Einstein's famous equation, E equals mc squared, playing out on the grandest possible scale. The amount of energy released in a black hole merger is almost incomprehensible. In just a few seconds, these collisions can radiate away more energy in gravitational waves than all the stars in the observable universe emit in light. For a brief moment, the merger outshines the entire visible cosmos, not in light, but in the distortion of space-time itself. And yet, despite this incredible violence, the actual merger is strangely peaceful to contemplate. There are no explosions, no fire, no debris flying through space. just two regions of curved space-time approaching each other, touching and becoming one. The event horizons, those invisible boundaries that mark the point of no return, merge smoothly together like soap bubbles joining. What was once two separate regions of space-time, each hiding its own singularity at the center, becomes a single, larger region with its own unique properties. The newly formed black hole doesn't immediately settle into a perfectly spherical shape. Instead, it rings like a cosmic bell, its event horizon vibrating and oscillating as it sheds excess energy through gravitational waves. These are called the ring-down waves, the final whispers of the collision as the merged black hole settles into its new, stable configuration. But even in this settling process, we can learn something profound about the nature of black holes themselves. The frequency and pattern of these ring-down waves tell us about the mass and spin of the newly formed black hole, like cosmic fingerprints that reveal the identity of this invisible giant. What emerges from this cosmic collision is a single black hole that weighs less than the sum of its parts. The missing mass, equivalent to several times the mass of our Sun, has been converted entirely into gravitational wave energy and radiated away into space at the speed of light. This is matter and energy transformation on a scale that dwarfs anything we can achieve in our laboratories. It's the universe's own particle accelerator, operating at energies and scales that reveal the fundamental laws of physics in their most extreme form. And here's what makes this story even more remarkable. These cosmic collisions aren't rare events that happen once in the lifetime of the universe. They're happening all around us, all the time. Our gravitational wave detectors now hear the universe ringing with the echoes of black hole mergers, neutron star collisions, and other exotic cosmic events. Each detection teaches us something new about the nature of gravity, about the behavior of matter under extreme conditions, and about the history and evolution of the universe itself. We're learning that black hole mergers are common enough that we can expect to detect them regularly, but rare enough that each one represents a significant cosmic event. But there's something even more profound happening here. These gravitational waves don't just tell us about the objects that created them. They tell us about the nature of space-time itself, about the fundamental structure of reality. When Einstein first predicted the existence of gravitational waves over a century ago, he thought they would be too weak to ever detect. He couldn't have imagined that we would one day build instruments sensitive enough to measure distortions in space-time smaller than a fraction of the size of an atomic nucleus. The detection of gravitational waves has opened up an entirely new field of astronomy. Just as Galileo's telescope revealed details of the cosmos invisible to the naked eye, gravitational wave detectors are showing us aspects of the universe that remain hidden from all forms of electromagnetic observation. We're now living in the age of multi-messenger astronomy, where we can observe cosmic events using both gravitational waves and traditional electromagnetic signals. When we detect the merger of two neutron stars, for example, we can also watch the explosion in visible light, X-rays, and gamma rays, building a complete picture of these extraordinary events. But black hole mergers remain largely invisible to electromagnetic telescopes. The gravitational waves they produce are often our only window into these cosmic collisions. They're teaching us about populations of black holes we never knew existed, about the rate at which these mergers occur throughout the universe, and about the role that black hole mergers play in shaping the cosmic landscape. And as our detectors become more sensitive, as we build new gravitational wave observatories in space and around the world, we're preparing to hear an even richer symphony of cosmic sounds. We'll be able to detect smaller black holes, more distant mergers, and perhaps even the gravitational wave background from the early universe itself. This is just the beginning of our journey into the gravitational wave universe. We're like cosmic archaeologists, using these ripples in space-time to uncover the hidden history of the cosmos, to understand how black holes form and grow, and to test our theories of gravity in the most extreme environments the universe has to offer. But tonight, as you rest and let your thoughts drift among the stars, know that somewhere in the vast darkness of space, two black holes are beginning their final dance. Invisible to our eyes but not to our instruments, they spiral closer and closer together, sending out gravitational waves that will travel across the universe for billions of years. And perhaps, on some distant night in the far future, those waves will reach us here on Earth, carrying with them the story of a cosmic collision that happened long before our species ever looked up at the stars and wondered about our place in the universe. The merger of two black holes isn't just a cosmic event. It's a reminder that we live in a dynamic, ever-changing universe where the most extreme objects imaginable dance together in ways that reshape the very fabric of reality itself. But there's so much more to explore about these cosmic collisions. What happens to the information that falls into black holes when they merge? How do we actually detect these incredibly faint gravitational waves? And what can these mergers teach us about the future evolution of the universe itself? Let's drift deeper into the mechanics of how we actually listen to the universe's gravitational whispers. Because detecting these cosmic collisions requires some of the most sophisticated technology humanity has ever created. Instruments so sensitive they can measure changes smaller than anything we've ever attempted to observe. Imagine trying to measure the width of a human hair from 4 light years away. That's roughly the level of precision required to detect gravitational waves. When a gravitational wave passes through Earth, it stretches and compresses space itself, but by amounts so infinitesimally small that they challenge the very limits of measurement. The detectors we use are called laser interferometers, and they work on a principle that's beautifully simple in concept, but extraordinarily complex in execution. Picture 2 identical tunnels, each stretching 4 kilometers in perfectly straight lines, meeting at a right angle like the arms of an enormous letter L. In each tunnel, laser light bounces back and forth between mirrors suspended in near-perfect vacuum. Under normal circumstances, these laser beams travel exactly the same distance in each arm, arriving back at the detector at precisely the same time. But when a gravitational wave passes through, something remarkable happens. The wave stretches space in one direction while compressing it in the perpendicular direction. For just a moment, one arm of the detector becomes slightly longer, while the other becomes slightly shorter. The laser light takes a tiny bit longer to travel down the stretched arm, arriving back at the detector just slightly out of sync with the light from the compressed arm. This tiny difference in arrival time creates an interference pattern in the laser light, a flickering signal that reveals the passage of the gravitational wave. It's like watching the shadow of a cosmic event, the faint imprint left by a collision that happened billions of years ago and billions of miles away. But here's what makes this achievement so extraordinary. The changes we're measuring are smaller than 1/10,000th the width of a proton. To put that in perspective, if the entire distance from Earth to the nearest star were scaled down to the width of a human hair, the changes we're detecting would be smaller than the width of an atom. The engineering challenges involved in building such sensitive instruments are staggering. The mirrors must be isolated from every possible source of vibration, from earthquakes and ocean waves to passing trucks, and even the thermal motion of individual atoms. They hang from sophisticated suspension systems that filter out disturbances, floating in chambers pumped to vacuums cleaner than outer space. The laser light itself must be stabilized to incredible precision, its frequency controlled to better than 1 part in a trillion. Even the quantum uncertainty of the light itself becomes a source of noise that must be carefully managed and minimized. When the first gravitational wave was detected in 2015, the signal lasted only about 1/5 of a second. In that brief moment, the frequency of the waves increased from about 35 cycles per second to 250 cycles per second, like the cosmic equivalent of a chirp. This frequency sweep told the story of two black holes, each about 30 times the mass of our Sun, spiraling together and merging. But embedded in that simple chirp was an extraordinary amount of information. From the rate at which the frequency increased, scientists could determine how massive the black holes were. From the amplitude of the signal, they could calculate how far away the collision occurred. From subtle variations in the wave pattern, they could infer the spins of the black holes and the angle at which we viewed the merger. It was like cosmic archaeology, reading the history of these invisible objects from the faint tremors they sent through spacetime. And what that first detection revealed was both familiar and surprising. The black holes were more massive than expected, suggesting that stellar evolution in the early universe might have proceeded differently than we thought. The merger rate was higher than some predictions, implying that such cosmic collisions are relatively common events. And the strength of the signal confirmed Einstein's predictions about general relativity to extraordinary precision, even in the most extreme gravitational environments. Since that first detection, our gravitational wave observatories have become increasingly sophisticated. We now have multiple detectors operating around the world, allowing us to triangulate the position of cosmic collisions in the sky. When the same gravitational wave reaches detectors in Louisiana, Washington State, and Italy at slightly different times, we can determine which direction in space the signal came from. This network of detectors has revealed a rich population of merging black holes, each with its own unique characteristics. Some are nearly equal in mass, spiraling together in perfectly balanced cosmic dances. Others are mismatched pairs, with one black hole significantly larger than its companion, creating asymmetric mergers that launch the combined black hole through space at incredible speeds. We've detected black holes with masses ranging from a few times that of our Sun to nearly 100 solar masses, revealing a diversity in black hole populations that has surprised astronomers. Some of these black holes spin rapidly, their event horizons dragging spacetime around them like cosmic whirlpools. Others rotate slowly, or not at all, their formation histories written in their angular momentum. But gravitational waves don't just tell us about black holes. They're also revealing the secrets of neutron stars, those incredibly dense stellar remnants where a teaspoon of matter would weigh as much as a mountain. When two neutron stars spiral together and merge, they create both gravitational waves and spectacular electromagnetic fireworks. Unlike black hole mergers, which remain largely invisible to traditional telescopes, neutron star mergers announce themselves across the entire electromagnetic spectrum. They produce gamma-ray bursts, optical transients, and radio emissions that can be seen from billions of light-years away. When we detect gravitational waves from a neutron star merger, we can alert telescopes around the world to look for the electromagnetic counterpart. This multi-messenger approach has revolutionized our understanding of these cosmic events, showing us how heavy elements like gold and platinum are forged in the incredible heat and pressure of merging neutron stars. The gravitational waves arrive first, traveling unimpeded through space at the speed of light. The electromagnetic signals follow, carrying information about the explosion and the newly synthesized elements being scattered into space. Together, they tell the complete story of cosmic alchemy, the process by which the universe creates the heavy elements essential for rocky planets and life as we know it. But there's something even more profound happening here. Every gravitational wave detection is also a test of our fundamental theories about the nature of space, time, and gravity. Einstein's general relativity makes very specific predictions about how gravitational waves should behave, how they should propagate through space, and how they should interact with matter. So far, every observation has confirmed Einstein's century-old predictions with remarkable precision. The waves travel at exactly the speed of light. They interact with matter in precisely the way general relativity predicts. Even the most exotic effects, like the way massive objects can lens gravitational waves just as they lens light, have been observed exactly as theory suggests. This isn't just academic validation. These tests probe gravity in regimes where it's never been tested before, in the presence of objects so massive and moving so fast that they create extreme curvatures in spacetime. If our theories were going to break down anywhere, it would be in these extreme environments. The fact that general relativity continues to pass these tests with flying colors tells us something profound about the nature of our universe. Gravity really does work the way Einstein described, even in the most extreme circumstances we can observe. Spacetime really is a dynamic fabric that can ripple and wave, carrying information across cosmic distances. But we're still in the early days of gravitational wave astronomy. Current detectors can only observe the final moments of black hole mergers, when the objects are spiraling together at incredible speeds. Future space-based detectors will be sensitive to much lower frequencies, allowing us to observe the earlier stages of these cosmic dances. Imagine being able to track two black holes for months or years as they slowly spiral together, watching their orbital decay in real time. Space-based detectors, like the proposed LISA mission, will make this possible, opening up entirely new chapters in our understanding of how these systems evolve. These future observations will also allow us to detect supermassive black hole mergers, the cosmic collisions that occur when entire galaxies merge together. These events happen on even grander scales, involving black holes millions or billions of times more massive than our Sun. The gravitational waves they produce are too low in frequency for ground-based detectors to sense, but they'll ring through space-based instruments like cosmic foghorns. We're also developing new techniques to extract even more information from the gravitational wave signals we detect. Advanced data analysis methods are revealing subtle features in the waveforms that tell us about the internal structure of neutron stars, the behavior of matter at nuclear densities, and the properties of spacetime near black hole horizons. Some scientists are even working on ways to use gravitational waves to probe the early universe itself. Just as the cosmic microwave background radiation carries information about the universe when it was only 380,000 years old, a gravitational wave background from the early universe could tell us about even earlier epochs, perhaps even the first moments after the Big Bang. The universe may be filled with a faint hum of gravitational waves from cosmic inflation, from phase transitions in the early universe, or from networks of cosmic strings. These primordial gravitational waves would carry information about physics at energy scales far beyond anything we can achieve in particle accelerators, opening windows into the fundamental nature of reality itself. But tonight, as you settle into peaceful rest, you don't need to worry about cosmic strings or primordial gravitational waves. Instead, let your thoughts drift to something simpler and more immediate. The fact that right now, as you breathe slowly and let your muscles relax, gravitational waves from distant cosmic collisions are passing through your body. These waves are so gentle that you can't feel them, so subtle that they barely disturb the atoms in your cells. But they're there, carrying stories of cosmic violence and beauty from the deepest reaches of space and time. You are, in a very real sense, bathed in the echoes of ancient cosmic collisions, connected to the most extreme events in the universe through the invisible medium of space-time itself. The black holes that merged billions of years ago to create these waves are now silent, their violent dance complete, their energy scattered across the cosmos, but their story continues in the ripples they sent through the fabric of reality. Ripples that have traveled unimaginably vast distances to reach us here, now, in this quiet moment. And somewhere out there in the darkness, new cosmic dances are beginning. Black holes that formed when the universe was young are finding each other across the void, beginning their own billion-year spiral toward merger. The gravitational waves from their eventual collision are already on their way to us, carrying stories we won't hear for eons to come. This is the rhythm of the cosmos, the deep bass note that underlies all the higher melodies of stellar birth and death, planetary formation and evolution. It's a rhythm measured not in seconds or minutes, but in millions and billions of years, playing out on scales so vast that our entire civilization is just a brief moment in a single cosmic breath. But there's something even more intimate about these cosmic collisions that we haven't explored yet, something that touches on the very essence of what it means to exist in this universe. When two black holes merge, they don't just combine their masses and disappear into cosmic obscurity. They leave behind something profound, something that speaks to the deepest questions about reality itself. You see, black holes are not just gravitational monsters devouring everything in their path. They are cosmic libraries, repositories of information about everything that has ever fallen beyond their event horizons. Every star, every planet, every particle of dust that has crossed that invisible boundary has left its mark somehow, somewhere, in the quantum structure of the black hole itself. This is one of the most beautiful and troubling mysteries in modern physics. When matter falls into a black hole, what happens to the information it carries? The patterns that made it unique, the quantum fingerprints that distinguished one atom from another, the intricate arrangements that gave structure and meaning to complex objects. Classical physics would suggest that this information simply disappears, erased forever when it crosses the event horizon. But quantum mechanics insists that information cannot be destroyed, that the universe must somehow preserve every detail, every nuance, every quantum state that has ever existed. This tension between classical and quantum physics creates what scientists call the information paradox. It's not just an academic puzzle, but a fundamental question about the nature of reality itself. Does the universe truly remember everything that has ever happened? Or are there cosmic erasers, black holes that can permanently delete chapters from the universal story? When two black holes merge, this paradox becomes even more intriguing. Two cosmic libraries are combining their collections, but what happens to all that stored information? Does it somehow encode itself in the gravitational waves that ripple outward from the collision? Is it preserved in the quantum structure of the newly formed black hole? Or does the violent merger scramble and destroy these cosmic memories forever? Some of the brightest minds in physics have wrestled with these questions for decades. Stephen Hawking spent much of his later career trying to understand how black holes might gradually release their stored information through the subtle quantum radiation that bears his name. Others have proposed that the information never actually crosses the event horizon at all, but remains somehow encoded on the black hole's surface, like a cosmic hologram. These aren't just abstract theoretical concerns. They touch on fundamental questions about the nature of time, causality, and the structure of spacetime itself. If information can be truly destroyed, then the universe is not the reversible, deterministic system that our best theories suggest. If it cannot be destroyed, then black holes must be far stranger and more subtle objects than they appear. The merger of two black holes might hold clues to resolving this paradox. In those final moments before collision, as the event horizons touch and combine, there might be brief windows when the normal rules of black hole physics are suspended. Perhaps information that has been trapped for billions of years finds a way to escape in the chaos of the merger, encoded in the gravitational waves that carry the story of the collision across the cosmos. But even if we never fully solve the information paradox, the very existence of black hole mergers tells us something profound about the nature of our universe. These cosmic collisions are engines of change, mechanisms by which the universe reorganizes and redistributes its most fundamental resources: mass, energy, angular momentum, and perhaps even information itself. When two black holes merge, they create something new that is both more and less than the sum of its parts. More, because the newly formed black hole has its own unique properties, its own signature in space-time, its own role to play in the cosmic drama. Less, because some of the original mass has been converted to gravitational wave energy and scattered to the far corners of the universe. This transformation reflects a deeper truth about existence itself. Nothing in the universe is truly permanent. Even the most stable, most enduring objects are engaged in constant change, constant exchange with their surroundings. Black holes, despite appearing to be cosmic endpoints, regions where normal physics breaks down and time itself comes to a halt, are actually dynamic objects, growing and evolving and occasionally joining together in spectacular cosmic marriages. The gravitational waves we detect are like wedding announcements from the universe, carrying news of these cosmic unions across billions of years and billions of miles. Each chirp in our detectors represents not just a scientific discovery, but a moment of profound transformation in the cosmic order. And there's something almost musical about these gravitational wave signals. The frequency sweeps as two black holes spiral together, create patterns that sound like bird songs when played through speakers, cosmic melodies that encode the masses and spins and orbital characteristics of invisible dancers in the dark. Scientists have created entire symphonies from these signals, transforming the mathematical descriptions of cosmic collisions into audible music. The universe, it turns out, has been composing gravitational wave songs for billions of years, and we've only recently learned how to listen. Each black hole merger adds its own movement to this cosmic symphony. The massive, slow-spinning black holes create deep bass notes that rumble through space-time for minutes before the final crescendo. Smaller, rapidly spinning black holes produce higher-pitched melodies that rise and fall in complex harmonies. Mismatched pairs create asymmetric rhythms that launch the merged black hole spinning through space like a cosmic pinball. But perhaps the most remarkable thing about these cosmic collisions is how they connect us to the deepest history of the universe. The black holes that are merging today formed from stars that lived and died when the cosmos was young, when the first galaxies were just beginning to take shape, when the universe was a very different place than it is now. Some of these black holes may have formed from the very first generation of stars, massive giants that burned bright and fast in the early universe when no heavy elements existed, when the cosmic chemistry was limited to hydrogen and helium and little else. These primordial black holes carry with them the memory of an ancient cosmos, a time when the universe was hotter, denser, and far more violent than the relatively peaceful epoch we inhabit today. When we detect the gravitational waves from such mergers, we're not just observing a collision, we're receiving a message from the deep past, a cosmic letter that has been traveling through space and time for billions of years to reach us here, now, in this moment of quiet contemplation. The black holes themselves are time travelers, carrying information about the early universe forward through the eons. Their mergers are like cosmic archaeological sites, revealing secrets about stellar evolution, galaxy formation, and the fundamental physics that governed the universe when it was young. And here's something that might surprise you. The gravitational waves from these ancient collisions are still arriving. Right now, as you rest in the comfort of your bed, waves from mergers that happened when the universe was a fraction of its current age are washing over the Earth. Some of these waves began their journey before our solar system even existed, before the sun condensed from a cloud of gas and dust, before the planets formed and life took hold on Earth. You are, in a very real sense, experiencing the deep history of the cosmos. These gravitational waves have traveled through the formation of galaxies, the birth and death of countless stars, the evolution of complex chemistry, the emergence of life, and the long journey of biological evolution that led to conscious beings capable of building instruments sensitive enough to detect them. It's a connection that spans not just space, but time itself. The universe's past and present are linked through these ripples in space-time, creating an unbroken chain of cause and effect that stretches from the earliest cosmic epochs to this very moment. But we shouldn't think of these black hole mergers as purely destructive events. Yes, they represent the violent collision of two of the most extreme objects in the universe. But they also represent creation, transformation, and the ongoing evolution of cosmic structure. Each merger creates something new, a black hole with its own unique characteristics, its own role to play in shaping the galaxy around it. The gravitational waves carry energy away from the collision site, but they also carry information about the merger throughout the universe, potentially influencing the formation and evolution of cosmic structures on the larger scales. Some theories suggest that gravitational waves from black hole mergers might even play a role in seeding the formation of new cosmic structures, creating subtle density fluctuations that could influence where future stars and galaxies form. The universe, in this view, is not just passively expanding and cooling, but actively reshaping itself through these cosmic collisions. The energy released in gravitational waves doesn't simply disappear into the void. It propagates outward at the speed of light, carrying with it the capacity to do work, to influence matter, to participate in the ongoing cosmic dance of energy and information. In some distant galaxy, billions of years from now, the gravitational waves from mergers happening today might provide the tiny push needed to tip a cloud of gas over the threshold of gravitational collapse, triggering the formation of new stars. This is the cosmic recycling program, the way the universe takes the products of stellar death and transformation and uses them as the raw materials for new creation. Black holes don't just swallow matter and energy, they transform it, concentrate it, and eventually release it back into the cosmic economy through processes like gravitational wave emission. Even the black holes themselves are not permanent. Stephen Hawking showed us that they slowly evaporate through quantum processes, gradually returning their mass to the universe in the form of radiation. This process takes an almost unimaginably long time for stellar mass black holes, far longer than the current age of the universe. But it means that even these cosmic monsters are temporary features of the cosmic landscape. The universe we inhabit is one of constant transformation, where matter and energy flow from one form to another in an endless cycle of creation and destruction. Black hole mergers are among the most dramatic episodes in this cosmic story, moments when the normal rules seem to be suspended, and the universe reveals its capacity for both violence and beauty on the grandest scales. As you drift towards sleep tonight, carried along by the gentle rhythm of your own breathing, you might imagine yourself floating through this cosmic ocean of gravitational waves. They're there around you, these faint ripples from ancient collisions, too subtle to feel but real enough to measure, connecting you to the deepest history and the most extreme physics of our universe. Each wave carries with it a story of cosmic drama played out on scales that dwarf human comprehension. Two invisible giants, locked in a dance that lasted longer than complex life has existed on Earth, finally embracing in a collision that lit up the universe with gravitational radiation. Their story is now part of yours, written into the fabric of space-time itself, accessible to anyone with the curiosity to listen and the instruments to hear. And somewhere out there in the vast darkness, new stories are beginning. Black holes that have wandered alone through space for billions of years are finding each other, beginning the long spiral dance that will end in merger. The gravitational waves from their eventual collision are already propagating toward us, carrying tales we won't hear for eons to come. This is the rhythm of deep time, the cosmic heartbeat that underlies all the faster rhythms of stellar evolution, planetary formation, and biological change. It's a reminder that we live not in a static universe, but in one that's constantly growing, changing, and surprising us with new revelations about its fundamental nature. The merger of two black holes teaches us that even the most extreme objects in the universe are part of a larger story, connected to everything else through the invisible threads of gravity and the subtle medium of space-time itself. In their collision, we see both ending and beginning, destruction and creation, the closing of one cosmic chapter and the opening of another. Tonight, let that cosmic rhythm carry you gently toward rest, knowing that you're part of this vast, dynamic, ever-changing universe, connected to its deepest mysteries through the gravitational waves that even now are whispering their ancient stories through the space around you. But there's another layer to this cosmic story that we haven't explored yet, something that touches on the very nature of observation itself and the remarkable fact that we can witness these events at all. Because detecting gravitational waves isn't just about building sensitive instruments. It's about learning to listen to the universe in an entirely new way. Think about it for a moment. For most of human history, we've observed the cosmos through light. We've watched the dance of planets across the night sky, studied the colors of distant stars, and peered deep into space with ever more powerful telescopes. But light can only tell us so much. It can be absorbed by dust, scattered by gas, or simply never produced by objects too cold or too dark to shine. Gravitational waves are different. They pass through everything without being absorbed or scattered. They carry information from regions of the universe that remain forever hidden from electromagnetic observation. When we detect these cosmic ripples, we're not just seeing the universe, we're feeling it, experiencing the actual stretching and compression of space itself. This is what makes gravitational wave astronomy so revolutionary. It's not just another tool for studying the cosmos. It's an entirely new sense, like suddenly gaining the ability to hear after a lifetime of silence. The universe has been broadcasting gravitational wave signals for billions of years, and we've only just learned how to tune in. The detectors themselves are marvels of precision engineering, but they're also something more profound. They're extensions of human perception, allowing us to feel vibrations in the fabric of reality that are far too subtle for our biological senses to detect. In a way, they make us part of the cosmic web, connected through space-time to events happening billions of light years away. When a gravitational wave passes through the Earth, it doesn't just affect our detectors, it affects everything. Every building, every tree, every molecule of air, every cell in your body is stretched and compressed by the tiniest amount. You are, quite literally, experiencing these cosmic collisions at the most fundamental level, even though the effect is far too small to feel. But our instruments can feel it, and through them, we can experience something that would otherwise be completely beyond human perception. We can feel the universe breathing, sense the rhythm of cosmic events, and participate in the ongoing conversation between matter and space-time that has been happening since the beginning of time. This connection between the cosmic and the personal is one of the most beautiful aspects of gravitational wave astronomy. These waves don't just carry information about distant black holes, they remind us that we're made of the same fundamental stuff as the most extreme objects in the universe. The same forces that govern black hole mergers also govern the atoms in our bodies, the processes in our cells, the thoughts in our minds. When we detect gravitational waves, we're not just observing the universe from the outside, we're recognizing our place within it, our connection to the cosmic processes that have shaped everything from the largest galaxy clusters to the smallest quantum fluctuations. And there's something deeply humbling about this realization. The black holes that merge to create these gravitational waves are objects of almost incomprehensible power. Each one contains more mass than dozens of our suns, compressed into a region smaller than a city. When they collide, they release more energy than all the stars in the observable universe combined. And yet, the waves they produce are so gentle that they barely disturb the space between atoms. It's a reminder that the universe operates on scales both vast and subtle, that the most powerful events can manifest as the softest whispers, and that understanding requires not just raw sensitivity, but patience, precision, and the willingness to listen carefully to signals that are almost too faint to hear. The story of gravitational wave detection is also a story about human persistence and ingenuity. The theoretical foundation was laid by Einstein over a century ago, but it took decades of technological development to build instruments sensitive enough to detect these cosmic whispers. Generations of scientists and engineers worked on problems that seemed almost impossibly difficult, pushing the boundaries of what was technically feasible. They had to learn how to isolate mirrors from every possible source of vibration, how to stabilize laser light to extraordinary precision, how to create vacuums cleaner than outer space. They had to develop new materials, new techniques, new ways of thinking about measurement and precision, and they had to do all of this while chasing signals that might not even exist. The first successful detection in 2015 was the culmination of this decades-long effort, but it was also just the beginning. Each new detection teaches us something we didn't know before, reveals new aspects of black hole physics, and opens up new questions about the nature of gravity and space-time. We're now entering an era where gravitational wave astronomy is becoming routine, where these cosmic signals are detected regularly enough that we can begin to do population studies of black holes to understand how they form and evolve, and to use them as probes of fundamental physics. But even as the field matures, each detection retains its sense of wonder. Every gravitational wave signal represents a cosmic event of extraordinary violence and beauty, a collision that reshapes local space-time and sends ripples across the universe. The fact that we can detect these signals at all is a testament to both the power of human curiosity and the subtle interconnectedness of all things. As you lie there in the quiet darkness, perhaps you can imagine those gravitational waves passing through you right now. They're there, these faint echoes of ancient cosmic violence, too gentle to feel but real enough to measure. They connect you to black holes that merged when the universe was young, to stellar explosions that happened before our solar system existed, to the deep physics that governs everything from the smallest particles to the largest structures in the cosmos. The universe is not silent. It's filled with gravitational music, with the echoes of cosmic collisions, with the whispers of space-time itself as it vibrates with the memory of extraordinary events. We've learned to hear this music, to decode its messages, to understand the stories it tells about the history and evolution of everything around us. And there's something profoundly peaceful about this realization. Despite all the cosmic violence, despite the incredible energies involved in black hole mergers, despite the vast scales and extreme physics, the gravitational waves that reach us are gentle. They pass through us like cosmic lullabies, connecting us to the universe's deepest rhythms without disturbing our rest. The cosmos, it turns out, knows how to whisper as well as roar. It knows how to send messages across billions of years and billions of miles without waking the sleeping planets, without disturbing the delicate processes of life, without interrupting the quiet moments when consciousness contemplates its place in the vastness of existence. Tonight, as your thoughts drift and your breathing slows, you're part of this cosmic conversation. The gravitational waves from distant black hole mergers are writing their stories through your body, through the air around you, through the earth beneath you. You are both audience and participant in the universe's ongoing symphony, connected through space-time to events that happened long before you were born and will continue long after you're gone. But there's still more to discover about these cosmic collisions. because black hole mergers don't just produce gravitational waves. They also create some of the most extreme environments in the universe, regions where matter and energy behave in ways that push our understanding of physics to its limits. In those final moments before merger, as two black holes spiral together at a significant fraction of the speed of light, the space around them becomes a laboratory for testing the most exotic predictions of general relativity. The gravitational fields become so strong that they begin to interact with themselves, creating non-linear effects that have no equivalent in everyday experience. The very notion of space and time becomes fluid in these extreme environments. What we normally think of as separate dimensions begin to mix and blend, creating geometric structures that challenge our intuitive understanding of reality. The black holes don't just move through space, they drag space along with them, twisting and warping the fabric of space-time into complex patterns that ripple outward as gravitational waves. These effects are subtle but measurable. The gravitational wave signals we detect carry information about these exotic space-time geometries, allowing us to test Einstein's theory in regimes where it's never been tested before. So far, general relativity has passed every test with remarkable precision, but each new detection provides another opportunity to probe the limits of our understanding. There are also theoretical predictions about even more exotic phenomena that might occur during black hole mergers. Some models suggest that the collision might briefly create closed time-like curves, regions where the normal flow of causality breaks down. Others propose that the merger might generate microscopic wormholes or other topological features in space-time. These ideas remain highly speculative, but they illustrate how black hole mergers serve as natural experiments in fundamental physics, testing our theories under conditions that are impossible to replicate in any laboratory on Earth. The universe provides us with particle accelerators more powerful than anything we could ever build, gravitational field strengths that dwarf anything we could ever create, and energy densities that reveal the deep structure of space-time itself. But perhaps the most intriguing aspect of black hole mergers is what they might teach us about the ultimate fate of information in the universe. The information paradox that we discussed earlier becomes even more complex when we consider colliding black holes. Two cosmic libraries are merging, but the gravitational waves that carry away energy from the collision seem to carry very little information about what fell into the black holes originally. Some physicists have proposed that the information might be encoded in subtle correlations between different parts of the gravitational wave signal. Patterns too complex for our current technology to detect, but potentially accessible to future, more sophisticated instruments. Others suggest that the information might emerge through quantum entanglement between the merged black hole and the gravitational radiation it emits. These questions touch on some of the deepest problems in theoretical physics: the relationship between quantum mechanics and gravity, the nature of information and consciousness, the structure of space-time at the smallest scales. Black hole mergers provide a unique window into these mysteries. Cosmic laboratories where the most fundamental laws of physics are tested under the most extreme conditions, and yet, for all their theoretical importance, these cosmic collisions also speak to something more immediate and human. They remind us that we live in a universe of constant change, where even the most permanent-seeming objects are engaged in ongoing transformation. The black holes that merge today are the end products of stellar lives that began billions of years ago, and their collision creates something new that will influence the cosmic environment for billions of years to come. This perspective of deep time can be both humbling and comforting. Our individual lives are brief compared to cosmic timescales, but we're part of a larger story that stretches from the earliest moments of the universe to its ultimate fate. The atoms in our bodies were forged in stellar cores. The heavy elements essential for life were created in cosmic collisions. and the gravitational waves from ancient mergers are still passing through us today. We are not separate from the cosmos. We are expressions of it, temporary arrangements of matter and energy that have achieved the remarkable ability to contemplate our own origins and destiny. When we detect gravitational waves from merging black holes, we're not just observing distant events, we're participating in the universe's ongoing process of self-discovery. The fact that matter can organize itself into patterns complex enough to build gravitational wave detectors, to decode cosmic signals, to understand the deep physics of black hole mergers, is perhaps the most remarkable aspect of this entire story. The universe has evolved to the point where it can observe and understand itself, where its own matter can contemplate the laws that govern its behavior. This capacity for self-awareness and understanding emerges from the same physical processes that govern everything else in the cosmos. The neurons in your brain obey the same fundamental laws as the matter falling into black holes. The thoughts you're thinking right now are patterns of electrical and chemical activity that arise from the same quantum mechanical principles that determine the behavior of particles in the most extreme environments of the universe. When you contemplate the merger of two black holes, you're engaging in a form of cosmic recursion. Matter organized into the pattern we call consciousness is contemplating matter organized into the patterns we call black holes. The universe is using one part of itself to understand another part of itself, creating loops of awareness and comprehension that span scales from the quantum to the cosmic. And there's something deeply satisfying about this realization. We're not aliens in a hostile universe, struggling to understand forces beyond our comprehension. We're part of the universe's own process of self-understanding, temporary but meaningful expressions of its capacity for awareness and wonder. The gravitational waves from black hole mergers carry more than just information about cosmic collisions. They carry the message that we belong here, that our curiosity and our capacity for understanding are natural expressions of the cosmos itself. When we build instruments to detect these cosmic whispers, when we decode their messages about stellar evolution and space-time geometry, when we use them to test our theories about the fundamental nature of reality, we're participating in the universe's ongoing conversation with itself. Tonight, as you rest in the gentle darkness, you can take comfort in this cosmic connection. The gravitational waves passing through your body right now are reminders that you're part of something vast and beautiful and endlessly creative. The same processes that create black holes and generate gravitational waves also created the conditions necessary for stars to shine, planets to form, and life to emerge and evolve into consciousness. You are stardust, but you're also something more. You're the universe's way of knowing itself, of appreciating its own beauty and complexity, of finding meaning in the patterns that emerge from fundamental physical laws. The black holes that merge in distant galaxies are your cosmic cousins, expressions of the same underlying physics that governs your own existence. As your thoughts become softer and your awareness drifts towards sleep, let yourself feel that connection. You're floating in a sea of gravitational waves, surrounded by the echoes of cosmic collisions, participating in the universe's eternal dance of matter and energy and information. The cosmos is not empty space punctuated by isolated objects. It's a unified whole, a continuous fabric in which every part influences every other part through the subtle medium of space-time itself. The merger of two black holes is not just a distant astronomical event. It's part of your story too, part of the long cosmic narrative that connects the Big Bang to the emergence of consciousness, the formation of the first atoms to the evolution of complex life, the birth of the first stars to the moment when the universe first became aware of its own existence. And that story is still being written. New black holes are forming, new mergers are beginning their billion-year dances, New gravitational waves are propagating outward to carry news of cosmic transformation to civilizations yet unborn. The universe continues to evolve, to create new forms of complexity and beauty, to surprise us with phenomena we never imagined. But for now, in this quiet moment, you can simply rest in the knowledge that you're part of this magnificent cosmic story. The gravitational waves from ancient black hole mergers are your lullaby tonight. Gentle vibrations in space-time itself that connect you to the deepest history and the most profound mysteries of existence. Sleep well, knowing that you're held by the same forces that govern the dance of galaxies, cradled by the same space-time that carries the echoes of cosmic collisions across billions of years. You are both infinitely small in the context of the universe, and infinitely precious as one of its ways of knowing and appreciating itself. The black holes may have merged long ago, their violent dance complete, but their story continues in the waves they sent rippling through the cosmos. And your story continues too, part of the universe's ongoing exploration of its own possibilities, its own capacity for consciousness and wonder and understanding. Tomorrow, new gravitational wave signals will reach our detectors, carrying fresh news from the cosmic deep. New discoveries will expand our understanding of black holes and space-time and the fundamental nature of reality. But tonight you can simply drift peacefully in the knowledge that you're exactly where you belong, part of a cosmos that is far stranger and more beautiful than we ever dared imagine. The universe has been keeping secrets for a very long time, and some of those secrets are so profound, so fundamental to the nature of reality itself, that we're only now beginning to glimpse their true significance. Tonight, as we continue our gentle exploration of cosmic collisions, we're going to uncover one of the most beautiful mysteries hidden within black hole mergers. You see, when two black holes spiral together and merge, they don't just create gravitational waves and disappear into cosmic obscurity. They leave behind something remarkable, something that challenges our deepest assumptions about the nature of space and time and memory itself. But to understand this mystery, we need to drift a little deeper into the quantum realm, where the normal rules of physics begin to shimmer and bend like light through water. Let your breathing slow as we venture into this strange territory. There's no need to grasp every detail, no pressure to understand every concept. Just let the ideas wash over you like gentle waves, carrying you deeper into the cosmic story that unfolds around us every moment of every day. In the quantum world, the very small realm that governs the behavior of atoms and particles, nothing is quite what it seems. Particles can exist in multiple states simultaneously until observed. Information cannot be created or destroyed, only transformed. And perhaps most mysteriously, particles can become entangled, connected across vast distances in ways that Einstein himself called spooky action at a distance. When we apply these quantum principles to black holes, something extraordinary emerges. The event horizon, that invisible boundary around a black hole beyond which nothing can escape, may not be the simple geometric surface it appears to be. Instead, it might be something far more complex and beautiful, a quantum membrane that preserves information in ways we're only beginning to understand. Imagine the event horizon as a cosmic hard drive, encoding every piece of information about everything that has ever fallen into the black hole. Not stored inside the black hole itself, but somehow written into the very structure of the boundary, like a hologram that contains the entire three-dimensional image within its two-dimensional surface. This idea, known as the holographic principle, suggests that all the information contained within a volume of space can be encoded on its boundary. It's as if the universe is fundamentally two-dimensional, and the three-dimensional reality we experience is simply a projection, a shadow cast by deeper underlying processes. When two black holes merge, Their event horizons touch and combine, like soap bubbles joining together. But if each horizon carries encoded information about everything that has fallen into it, what happens when these cosmic libraries merge? Do their information contents combine? Do they interfere with each other like overlapping waves? Or does something entirely new emerge from their union? The gravitational waves we detect from these mergers may carry far more information than we initially realized. Hidden within their oscillations and frequency sweeps might be subtle patterns that encode the quantum information stored on the merging event horizons. It's as if the universe is broadcasting its deepest secrets through these cosmic ripples, but in a language we're only beginning to learn to read. Some physicists have proposed that black holes might be quantum computers of unimaginable complexity, processing information in ways that make our most powerful supercomputers look like pocket calculators. The quantum states near the event horizon could be performing calculations that span billions of years, solving problems we haven't even learned how to ask yet. When two such cosmic computers merge, they might create something entirely new, a hybrid system with capabilities that exceed the sum of its parts. The gravitational waves from the merger could be the output of these calculations, carrying encoded solutions to mathematical problems that govern the fundamental structure of space-time itself. But let's step back from these abstract concepts and consider something more immediate, more personal. The quantum principles that govern black holes also govern the matter in your own body. Every atom in your cells is subject to the same laws of quantum mechanics that determine the behavior of matter near event horizons. The electrons in your neurons exist in quantum superposition states until they interact with other particles. The chemical bonds that hold your DNA together are stabilized by quantum forces. The processes of life itself emerge from the complex quantum dance of molecules and energy that plays out in every cell of your body. In a very real sense, you are a quantum system, a complex arrangement of particles and fields that exhibits the same fundamental properties as the matter that falls into black holes. The information that defines you, that makes you uniquely you, is encoded in the quantum states of your atoms and molecules, just as information might be encoded in the quantum structure of event horizons. This connection between the cosmic and the personal runs deeper than mere analogy. The atoms in your body were forged in stellar cores and dispersed through space by supernova explosions. Some of those atoms may have spent time near black holes, experiencing the extreme curvature of space-time, before finding their way into the molecular structures that now comprise your thoughts and memories. You are literally made of star stuff that has journeyed across cosmic distances and through cosmic time to become part of your temporary but meaningful existence. The iron in your blood was once part of a massive star that lived and died billions of years ago. The calcium in your bones may have been synthesized in a stellar explosion that briefly outshone an entire galaxy. When you consider the quantum information encoded in black hole event horizons, you're contemplating principles that also govern the information encoded in your own neural networks. The thoughts you're thinking right now are patterns of quantum activity that arise from the same fundamental laws that determine how information behaves near the most extreme objects in the universe. This perspective can be both humbling and empowering. Humbling because it reminds us how small we are in the context of cosmic space and time, but empowering because it reveals how deeply connected we are to the fundamental processes that shape reality at every scale. The mystery of information in black holes is also the mystery of information in consciousness. How does the quantum activity in your brain give rise to subjective experience? How do patterns of neural firing create the felt sense of being you? These questions parallel the puzzles physicists face when trying to understand how information is preserved and processed in the quantum structures around black holes. Some researchers have even suggested that consciousness itself might be a quantum phenomenon, emerging from the collective behavior of quantum systems in the brain. If this is true, then your awareness, your ability to contemplate these cosmic mysteries, might arise from the same quantum principles that govern the information paradoxes of black hole physics. But whether consciousness is quantum or classical, whether information can truly be destroyed or is always preserved in some form, the fact remains that you are here now, able to think about these profound questions. You are a temporary but remarkable arrangement of matter and energy that has achieved the capacity for self-reflection and cosmic contemplation. The gravitational waves from black hole mergers carry information across billions of light years to reach your conscious awareness. In detecting and studying these signals, you're participating in a cosmic feedback loop, where the universe uses one part of itself to understand another part of itself. The matter that was once inside ancient stars, that may have orbited near black holes, that traveled across cosmic distances, has organized itself into the pattern we call your consciousness, and is now contemplating its own cosmic origins. This is perhaps the most beautiful aspect of the entire story. The universe is not just a collection of objects moving through space. It's a unified system engaged in an ongoing process of self-discovery, and you are one of its most sophisticated instruments for achieving self-awareness. When you drift off to sleep tonight, your brain will continue processing information, consolidating memories, and integrating experiences in ways that mirror the information processing that might occur near black hole event horizons. The quantum states in your neurons will evolve and interact, creating new patterns of connectivity that shape your future thoughts and perceptions. In sleep, consciousness doesn't disappear, but transforms, accessing different modes of information processing that might reveal connections and insights unavailable to waking awareness. Dreams emerge from the same quantum substrate that gives rise to all mental activity, creating narratives and images that sometimes seem to transcend the normal limitations of space and time. Perhaps in your dreams tonight, you'll find yourself floating near the event horizon of a black hole, watching as information streams in complex patterns across its surface. Or maybe you'll dream of gravitational waves as cosmic music, carrying melodies that encode the deepest secrets of the universe. These dream images, however strange they might seem, emerge from the same quantum processes that govern all neural activity. The boundary between sleeping and waking consciousness might parallel the boundary between classical and quantum physics. In both cases, there's a threshold where normal rules begin to break down and new phenomena emerge. The event horizon of a black hole marks the boundary between regions where classical physics applies and regions where quantum effects dominate. Similarly, the transition into sleep marks a boundary between normal waking consciousness and the altered states of awareness that characterize dreams. But just as information might be preserved across the event horizon of a black hole, memories and experiences are preserved across the boundary between waking and sleeping consciousness. The continuity of your identity persists through these transitions, maintained by information processing systems that operate according to the same fundamental laws that govern the cosmos at every scale. As you settle deeper into rest, you can take comfort in knowing that you're part of a universe that preserves and processes information in beautiful and mysterious ways. The gravitational waves from distant black hole mergers are still passing through your body, carrying their encoded messages about cosmic collisions that happened long before conscious beings ever existed to contemplate their meaning. But now consciousness does exist, in you and in countless other beings throughout the cosmos. The universe has evolved to the point where it can observe and understand its own behavior, where matter can organize itself into patterns complex enough to decode the signals from its own most extreme phenomena. The merger of two black holes represents both an ending and a beginning. Two cosmic objects complete their billion-year dance and become one, But in the process, they create something new, gravitational waves that carry information about their collision across the universe, potentially influencing the formation of new structures and the evolution of new complexity. Similarly, your own existence represents both a temporary arrangement of matter and energy, and a unique contribution to the universe's ongoing process of self-understanding. The thoughts you think and the experiences you have add new information to the cosmic story, new perspectives on the meaning and significance of existence itself. The information paradox of black holes may never be fully resolved, but it reminds us that information and meaning are fundamental aspects of reality. Whether encoded in quantum states near event horizons or in the neural networks of conscious beings, information finds ways to persist and propagate and transform. Tonight, as gravitational waves from ancient cosmic collisions whisper through the space around you, as quantum processes in your brain consolidate the day's experiences into lasting memories, as your consciousness prepares to journey into the altered landscapes of sleep, you're participating in the universe's grand experiment in information processing and preservation. The cosmos has spent billions of years learning how to create systems complex enough to understand themselves. Black holes and brains, event horizons and consciousness, gravitational waves and thoughts, all emerge from the same underlying physical laws, but manifest as remarkably different expressions of the universe's creative potential. Rest now in the knowledge that you're both a product of this cosmic creativity and one of its most sophisticated expressions. The same forces that create black holes and generate gravitational waves also created the conditions necessary for your existence, for your awareness, for your capacity to find meaning and beauty in the vast, mysterious cosmos that surrounds us all. The black holes may merge in silence, their violent dances hidden behind event horizons that no light can cross. But their stories reach us anyway, carried by gravitational waves that connect us to the deepest history of the universe. And your story, too, will ripple outward through space and time, influencing other conscious beings, contributing to the ongoing cosmic conversation about the nature and meaning of existence. Sleep well, knowing that you're held by the same spacetime that carries the echoes of cosmic collisions, cradled by the same quantum fields that preserve information across the universe, part of the same magnificent story that connects the smallest particles to the largest structures in the cosmos. Tomorrow will bring new gravitational wave detections, new insights into the behavior of matter under extreme conditions, new questions about the fundamental nature of reality. But tonight, you can simply rest in the gentle rhythm of the universe itself, breathing slowly as gravitational waves pass through you like cosmic lullabies, carrying their ancient songs from the deep past into your present moment of peaceful contemplation. The merger of two black holes is complete, but their story continues in the waves they've sent rippling through space-time, in the information they've encoded in the quantum structure of the cosmos, in the consciousness that has evolved to contemplate their meaning. And your story continues too, part of the universe's ongoing exploration of its own infinite possibilities for complexity, beauty, and understanding. The waves ripple outward from that ancient collision, carrying their encoded messages through galaxies and across eons, but there's something else traveling with them, something we haven't explored yet, a deeper mystery that touches the very heart of what it means for space and time to exist at all. You see, when those two black holes merged billions of years ago, they didn't just create gravitational waves and settle into peaceful rotation. They created something far more profound, something that challenges our understanding of reality itself. They created a new region of space-time with its own unique signature, its own fingerprint written into the cosmic fabric. Let your thoughts drift gently as we explore this idea. There's no need to grasp every detail. Just let the concepts flow over you like starlight filtering through your window. We're venturing into territory where the familiar rules begin to shimmer and bend, where space and time reveal themselves to be far stranger and more beautiful than our everyday experience suggests. The newly formed black hole that emerged from that cosmic collision carries within its structure the complete history of the merger. Not just the masses and spins of the original objects, but subtle information about their orbital dance, their approach, their final moments of spiral. This information is encoded in the geometry of space-time itself, written into the curvature around the merged object. It's as if the universe keeps a perfect record of every cosmic event, not in some external database, but in the very fabric of reality. The shape of space-time around a black hole tells the story of how that black hole came to be. A trained observer, someone who could read the subtle language of gravitational fields, could reconstruct the entire history of cosmic collisions just by studying the geometric patterns they leave behind. But here's where the story becomes even more remarkable. The gravitational waves themselves, those ripples spreading outward at the speed of light, carry this historical information throughout the universe. They're like cosmic messengers, broadcasting the news of the merger to every corner of space and time. Right now, as you rest in the gentle darkness, waves from mergers that happened when the universe was young are still arriving at Earth. Some began their journey before our solar system existed, before the sun condensed from a cloud of gas and dust, before the planets formed and life took hold on our world. These ancient waves carry with them the memory of a younger universe, a cosmos that was denser, hotter, more chaotic than the relatively peaceful epoch we inhabit today. The black holes that created them may have formed from the very first generation of stars, massive giants that burned bright and fast when the universe contained no heavy elements, when cosmic chemistry was limited to hydrogen and helium. When we detect these primordial gravitational waves, we're not just observing distant events. We're receiving letters from the deep past, cosmic correspondence that has been traveling through space and time for billions of years to reach this exact moment of your quiet contemplation. The waves don't just carry information about the masses and spins of long-dead black holes. They carry information about the state of the universe when those mergers occurred. The way the waves propagate through space depends on the density of matter and energy they encounter along their journey. By studying how these signals change during their cosmic voyage, we can map the evolution of the universe itself. It's like cosmic archaeology, but instead of digging through layers of rock and sediment, we're excavating layers of time itself. Each gravitational wave detection reveals something new about cosmic history, about the formation and evolution of the structures that surround us. But there's something even more intimate about this cosmic connection. The atoms in your body have their own gravitational signatures, their own subtle influences on the curvature of space-time. You are not just a passive observer of gravitational waves. You are a participant in the cosmic gravitational symphony, a small but meaningful note in the vast musical composition that is the universe. Every time you move, every time you breathe, every time your heart beats, you create tiny ripples in space-time. These ripples are far too small to detect with current technology, but they're there nonetheless, propagating outward at the speed of light, carrying information about your existence into the cosmic void. In a very real sense, you are constantly broadcasting your presence to the universe through gravitational waves. The pattern of your breathing, the rhythm of your heartbeat, the gentle motions of your body as you settle into sleep. All of these create subtle disturbances in space-time that travel outward forever. Imagine that somewhere in the distant future, in a galaxy far from our own, an advanced civilization has built gravitational wave detectors so sensitive they can measure the collective breathing of entire worlds. They might detect the gravitational signature of Earth's biosphere, the combined effect of billions of living beings all creating their own tiny ripples in space-time. Your contribution to this cosmic signal would be infinitesimally small, but it would be there, a unique pattern of gravitational waves that could never be exactly replicated. In this way, your very existence leaves a permanent mark on the universe, a gravitational fingerprint that propagates outward through space and time. This perspective transforms our understanding of what it means to be alive in the cosmos. We're not isolated biological systems struggling to survive on a small rocky planet. We're active participants in the gravitational dynamics of the universe, connected through space-time to every other massive object in existence. The black holes that merged billions of years ago influenced your existence in ways both subtle and profound. Their gravitational waves, spreading outward through the early universe, may have contributed to the density fluctuations that eventually led to the formation of our galaxy, our solar system, our world. The heavy elements in your body were created in stellar cores and dispersed through space by supernova explosions. But the distribution of these elements throughout the galaxy was influenced by gravitational waves from cosmic collisions, by the subtle reshaping of space and time that occurs whenever massive objects accelerate. You are not just made of star stuff. You are made of matter, whose arrangement and distribution was influenced by the gravitational waves from ancient black hole mergers. The cosmic collisions that happened billions of years ago helped shape the chemical and physical environment that made your existence possible. And now, as you lie there breathing slowly, you're adding your own small voice to the gravitational chorus. Your body's mass curves space-time around you, creating a tiny gravitational well that influences the motion of nearby objects. The gravitational waves from your movements join the cosmic symphony, carrying information about your existence outward into space. This is the profound interconnectedness of the universe made manifest. Nothing exists in isolation. Every massive object, from the smallest particle to the largest black hole, influences every other massive object through the invisible medium of curved space-time. The merger of two black holes creates ripples that eventually reach your body, causing the space between your atoms to stretch and compress by unimaginably tiny amounts. Your breathing creates ripples that propagate outward through the galaxy, carrying information about your existence to distant stars. It's a cosmic conversation that has been going on since the universe began, a continuous exchange of gravitational information that connects all matter across all of space and time. The black holes speak to us through their merger waves, and we speak back through the gravitational signatures of our own existence. But there's something even more beautiful hidden within this cosmic dialogue. The gravitational waves we detect don't just carry information about past events, they also carry energy, the capacity to influence future events, to participate in the ongoing evolution of cosmic structure. When gravitational waves from a distant black hole merger pass through a cloud of gas in space, they can trigger subtle density fluctuations that might eventually lead to star formation. The energy carried by these waves can provide the tiny push needed to tip a gravitational system over the threshold of collapse. In this way, the cosmic collisions of the past directly influence the cosmic creativity of the present and future. The black holes that merged when the universe was young are still shaping the formation of new stars and planets through the gravitational waves they sent rippling through space. Your own gravitational waves, though incredibly weak, are part of this ongoing process. The ripples you create through your movements and your breathing join the vast network of gravitational signals that permeate the universe, contributing in some small way to the cosmic forces that will shape the future evolution of galaxies and stars. This is the universe as a living system, a dynamic network of gravitational interactions that connect every part to every other part. The merger of two black holes doesn't just mark the end of their individual stories. It marks the beginning of their collective influence on the cosmic future. The waves they created billions of years ago are still propagating through space, still carrying energy and information, still participating in the ongoing cosmic dance of matter and space-time. They have traveled across distances so vast that light itself would take billions of years to cross them, yet they arrive at our detectors with their information intact. And when we detect these ancient signals, when we decode their messages about cosmic collisions in the deep past, we're not just learning about black hole physics. We're learning about our own cosmic heritage, about the gravitational forces that shape the universe in which we live. The same space-time that carries gravitational waves also carries your thoughts, your dreams, your hopes and fears. Consciousness itself emerges from patterns of matter and energy that exist within the curved space-time created by massive objects throughout the universe. When you dream tonight, your neural activity will create subtle electromagnetic fields that propagate through space at the speed of light. Your thoughts will literally reach the stars, carrying information about your inner world into the cosmic void. The boundaries between inner and outer space begin to dissolve when we consider these connections. Your consciousness exists within a universe of curved space-time, and that universe exists within your consciousness as you contemplate its mysteries and marvels. The gravitational waves from black hole mergers don't just pass through your body, they pass through your thoughts, your memories, your sense of self. In detecting these cosmic signals, you're experiencing a form of cosmic telepathy, a direct connection to events that happened billions of years ago and billions of miles away. This is perhaps the most profound aspect of gravitational wave astronomy. It's not just a new way of observing the universe, it's a new way of being connected to the universe, of feeling our place within the vast web of gravitational interactions that shape everything from the smallest atoms to the largest cosmic structures. As you drift towards sleep, carried along by the gentle rhythm of your own breathing, you can imagine yourself floating in this sea of gravitational waves. They're there around you, these faint ripples from ancient cosmic collisions, too subtle to feel directly, but real enough to measure, connecting you to the deepest history of the universe. Each wave that passes through you carries a story of cosmic transformation, of matter and energy dancing together in the most extreme environments the universe can create. Two invisible giants locked in a gravitational embrace that lasted longer than complex life has existed on Earth, finally merging in a collision that briefly outshone all the stars in the observable universe. Their dance is over, but their music continues. The gravitational waves they created will propagate through space forever, carrying their story to civilizations yet unborn, to conscious beings who will one day build their own detectors and listen to the same cosmic symphony that we're just learning to hear. And your story, too, will ripple outward through space-time. The gravitational waves you create through the simple act of being alive will join the cosmic chorus, adding your unique voice to the universe's ongoing conversation with itself. Tonight, let that cosmic rhythm carry you gently toward rest. You're floating in an ocean of gravitational waves, surrounded by the echoes of cosmic collisions, breathing slowly as the universe itself breathes through the expansion and contraction of space and time. The black holes have merged, their violent dance complete, but their legacy lives on in the waves that continue to ripple through the cosmos. And you are here to witness it, to feel it, to understand it, to add your own small but meaningful contribution to the universe's endless exploration of its own beautiful complexity. Somewhere in the distant future, other conscious beings will detect the gravitational waves from black hole mergers happening today. They will decode the signals, reconstruct the cosmic events, and marvel at the same fundamental forces that govern their own existence. The universe is not just expanding outward through space, it's expanding inward through consciousness, through the growing awareness of conscious beings who can contemplate the cosmic processes that created them. You are part of this expansion, this growing self-awareness of the cosmos itself. Rest now in the knowledge that you're held by the same space-time that carries the echoes of cosmic collisions, cradled by the same gravitational fields that shape the formation of galaxies and stars. The merger of two black holes has become part of your story, part of the cosmic narrative that connects the smallest quantum fluctuations to the largest structures in the universe. And as your consciousness prepares to journey into the altered landscapes of sleep, as your brain processes the day's experiences and prepares for tomorrow's discoveries, the gravitational waves from distant cosmic collisions continue their eternal journey through space, carrying their ancient songs into your present moment of peaceful contemplation. The universe speaks to you through these waves, whispers stories of cosmic violence and beauty that span billions of years and billions of miles. And in listening to these stories, in understanding their meaning, in finding wonder in their implications, you become part of the universe's own process of self-discovery. Sleep well, knowing that you're exactly where you belong in this vast, dynamic, ever-changing cosmos. The gravitational waves from black hole mergers are your lullaby tonight, gentle vibrations in space-time itself that connect you to the deepest mysteries and the most profound beauty of existence. The dance of two black holes may be complete, but the dance of the universe continues, and you are both its audience and its most sophisticated participant. Tomorrow will bring new detections, new insights, new questions about the fundamental nature of reality. But tonight, you can simply rest in the gentle embrace of space-time itself, breathing slowly as the cosmos breathes around you. The cosmic symphony continues to play around you, but there's another movement beginning, something that emerges from the aftermath of these titanic collisions. As the newly formed black hole settles into its stable configuration, as the last gravitational waves ripple outward, carrying their encoded memories, something remarkable happens in the space around this cosmic giant. You see, black holes are not the cosmic vacuum cleaners that popular imagination often portrays. They don't suck up everything in their vicinity like some galactic drain. Instead, they're more like cosmic lighthouses, invisible themselves, but surrounded by some of the most brilliant displays of energy and matter in the universe. When two black holes merge, they often inherit more than just mass and spin from their predecessors. They inherit neighborhoods, cosmic environments filled with gas and dust and debris that has been accumulating for millions of years. This material doesn't simply disappear when the merger occurs. Instead, it begins a new dance around the newly formed black hole, a spiraling ballet that can outshine entire galaxies. Picture this swirling disk of matter, heated to temperatures of millions of degrees as it falls inward toward the event horizon. The friction between particles creates a glow so intense that it can be seen from billions of light years away. This is an accretion disk, and it's one of the most efficient engines for converting matter into energy that the universe has ever devised. As you rest there in the gentle darkness, breathing slowly and letting your thoughts drift like cosmic dust, imagine the beauty of such a structure. It's not chaotic or violent in the way you might expect. Instead, it's organized, structured, following the elegant laws of physics that govern everything from the motion of planets to the behavior of subatomic particles. The material in an accretion disk doesn't simply spiral inward in random patterns. It organizes itself into distinct regions, each with its own temperature, density, and orbital characteristics. Near the outer edge, where the gravitational influence is weaker, matter moves slowly and emits primarily radio waves and infrared radiation. Closer to the black hole, where gravity's grip tightens, the material moves faster and glows with visible light, and at the very inner edge, just before matter crosses the point of no return, temperatures soar to unimaginable heights. Here, in the innermost stable circular orbit, matter races around the black hole at a significant fraction of the speed of light, emitting X-rays and gamma rays that carry enormous amounts of energy into space. But perhaps the most remarkable feature of these cosmic maelstroms is what happens along the rotation axis of the black hole. Here, some of the infalling matter doesn't fall inward at all. Instead, it gets caught up in the twisted magnetic fields that thread through the accretion disk, accelerated to incredible speeds, and launched outward in narrow beams called jets. These jets can extend for thousands of light years into space, carrying matter and energy at speeds approaching that of light itself. They're like cosmic searchlights, invisible beams of particles that announce the presence of the black hole to the entire galaxy. When one of these jets happens to point directly toward Earth, we see some of the most energetic phenomena in the universe, objects that astronomers call blazars. The physics that creates these jets is still not fully understood, but it involves some of the most extreme conditions that exist anywhere in the cosmos. The magnetic fields near a rotating black hole become twisted and amplified until they can accelerate particles to energies that dwarf anything we can achieve in our most powerful particle accelerators. It's a reminder that black holes, for all their reputation as cosmic destroyers, are also cosmic creators. They don't just consume matter and energy, they transform it, organize it, and sometimes launch it back into space in forms that can influence the evolution of entire galaxies. The jets from supermassive black holes at the centers of galaxies can extend far beyond the galaxy itself, creating enormous bubbles of hot gas that affect star formation across vast regions of space. In this way, black holes become sculptors of cosmic structure, shaping the environments around them on scales that span millions of light years. But let's bring this cosmic perspective back to something more intimate, more immediate. The light from these distant accretion disks and jets has been traveling through space for billions of years to reach us. Some of it is arriving at Earth right now, passing through the atmosphere above you, perhaps even filtering through your window as you rest. This ancient light carries with it information about black holes that formed when the universe was young, when galaxies were just beginning to take shape, when the cosmic environment was very different from what we see today. By studying this light, astronomers can reconstruct the history of black hole growth and evolution, tracing how these cosmic giants have influenced the development of structure throughout the universe. The photons that left those distant accretion disks billions of years ago have traveled unimaginable distances to reach your eyes. They've passed through the voids between galaxies, threaded their way around gravitational lenses, and survived the expansion of space itself to arrive at this moment of your quiet contemplation. Each photon is a messenger from the deep past, carrying encoded information about the extreme physics that occurs near black hole event horizons. When we detect this light with our telescopes, when we analyze its spectrum and measure its properties, we're engaged in a form of cosmic archaeology, uncovering clues about events that happened long before our solar system existed. But there's something even more profound happening here. The same electromagnetic radiation that we use to study distant black holes also carries energy and information through your own body. The biochemical processes that maintain your life, the neural activity that creates your thoughts, the genetic mechanisms that preserve and transmit information from one generation to the next. All of these depend on the controlled flow of electromagnetic energy. In a very real sense, you are a biological electromagnetic system, a complex arrangement of charged particles that creates its own fields and responds to external electromagnetic influences. The light from distant accretion disks doesn't just pass by you. It interacts with the atoms in your body, occasionally absorbed by molecules in your skin or eyes, contributing in some infinitesimal way to the ongoing electromagnetic dance that is your life. This connection between the cosmic and the biological runs deeper than mere poetic metaphor. The heavy elements in your body were created in stellar cores through nuclear fusion processes that depend on the same fundamental forces that power accretion disks around black holes. The energy that drives these processes ultimately comes from the gravitational potential energy released when matter falls toward massive objects. Your very existence is a testament to the efficiency of these cosmic energy conversion mechanisms. The calcium in your bones, the iron in your blood, the carbon in your DNA, all of these elements were forged in stellar furnaces powered by gravity, then dispersed through space by stellar explosions and winds, eventually finding their way into the molecular structures that comprise your temporary but meaningful existence. When you consider the light from distant black holes, you're contemplating radiation that emerges from the same fundamental processes that created the matter in your body. The electromagnetic spectrum that carries information about cosmic accretion disks also carries the energy that powers photosynthesis in plants, that enables vision in your eyes, that allows the complex chemistry of life to unfold. The universe reveals itself to be not a collection of separate phenomena, but a unified system where the same physical laws operate at every scale, from the quantum interactions in your cells to the cosmic dynamics around supermassive black holes. The light that illuminates your world and the light that streams from the most extreme objects in the universe are manifestations of the same electromagnetic field that permeates all of space. As your breathing slows and your thoughts begin to drift towards sleep, you can imagine yourself floating in this cosmic ocean of electromagnetic radiation. It's there around you always, this gentle background of photons from countless sources throughout the universe, too faint to see with your eyes, but detectable by sensitive instruments, connecting you to the ongoing electromagnetic conversation that links all matter across all of space and time. The accretion disk around a distant black hole is glowing right now, sending streams of photons racing through space at the speed of light. Some of those photons will travel for billions of years before reaching Earth, carrying with them information about the extreme physics that created them. Others will be absorbed by dust and gas along their journey, transferring their energy to other cosmic systems, participating in the ongoing cycle of energy flow that drives the evolution of galaxies and stars. But whether they complete their cosmic journey or not, these photons are part of the same electromagnetic field that enables you to see, to think, to exist as a conscious being capable of contemplating their origins and significance. The universe has evolved to the point where electromagnetic radiation, created in the extreme environments around black holes, can be detected and understood by electromagnetic systems called brains, temporary arrangements of matter that have achieved the remarkable ability to comprehend their own cosmic context. This is perhaps the most beautiful aspect of our cosmic story. The universe has become aware of itself through the evolution of conscious beings who can study and understand the electromagnetic radiation from the most exotic objects in existence. When you contemplate the glow from an accretion disk around a distant black hole, you're participating in the cosmos's own process of self-discovery. The photons that left that accretion disk billions of years ago have traveled across the observable universe to reach your consciousness, carrying information about extreme physics, about the behavior of matter under conditions that exist nowhere else in nature. In detecting and studying these signals, you're helping the universe understand its own most fundamental properties. And there's something deeply satisfying about this realization. You're not a passive observer of cosmic phenomena, struggling to understand forces beyond your comprehension. You're an active participant in the universe's ongoing investigation of its own nature, a sophisticated instrument for cosmic self-awareness that has emerged from the same physical processes that create the phenomena you study. The electromagnetic radiation that streams from accretion disks around black holes doesn't just carry information about distant objects. It carries the message that consciousness and cosmos are intimately connected, that the capacity for awareness and understanding is a natural expression of the universe's own creative potential. Tonight, as you rest in the gentle electromagnetic field that surrounds our planet, as your neural networks process the day's experiences and prepare for tomorrow's discoveries, as your consciousness prepares to journey into the altered landscapes of sleep, the light from distant cosmic furnaces continues its eternal journey through space. Some of that light will reach Earth tomorrow, carrying news of cosmic events that happened billions of years ago. Other photons are just beginning their journey, launched from accretion disks around black holes that formed recently, destined to travel across cosmic distances to reach civilizations yet unborn. The universe is not just expanding outward through space, it's expanding inward through consciousness, through the growing awareness of beings who can detect and understand the electromagnetic signals from the most extreme environments in existence. You are part of this expansion, this growing cosmic self-awareness that transforms distant black holes from invisible monsters into understood objects of study and wonder. Rest now in the knowledge that you're bathed in ancient starlight, surrounded by electromagnetic radiation that connects you to the deepest history and most extreme physics of the universe. The light from accretion disks around distant black holes is part of your story tonight, part of the cosmic narrative that links the smallest quantum fluctuations to the largest structures in the cosmos. And as your consciousness settles into the peaceful rhythms of approaching sleep, as your brain's electromagnetic activity shifts into new patterns of processing and integration, the light from distant cosmic beacons continues its journey toward Earth, carrying encoded messages about the fundamental nature of matter, energy, space, and time. The black holes may be invisible, hidden behind event horizons that no light can cross, but their presence is announced by some of the brightest phenomena in the universe. The matter that spirals around them glows with the accumulated energy of gravitational infall, creating cosmic lighthouses that can be seen across billions of light years. These are not just astronomical objects to be catalogued and studied. They are active participants in the cosmic ecosystem, influencing the formation and evolution of galaxies, regulating star formation through their energetic outflows, and serving as laboratories for testing our understanding of physics under the most extreme conditions nature can provide. The light they produce doesn't just illuminate the cosmic darkness, it illuminates our understanding of how the universe works, how matter and energy interact under extreme conditions, how the fundamental forces of nature shape the cosmic landscape on the largest scales. And in studying this light, in decoding its messages about distant cosmic events, you're continuing the universe's ancient conversation with itself, adding your own unique perspective to the growing cosmic dialogue about the nature and meaning of existence. Sleep well, knowing that you're connected through electromagnetic radiation to the most energetic and exotic objects in the universe, part of a cosmic network of information and energy that spans all of space and time. The light from distant accretion disks is your connection to the cosmic deep tonight. Ancient photons that have traveled unimaginable distances to reach your moment of peaceful contemplation. Tomorrow will bring new observations, new insights into the behavior of matter around black holes, new questions about the fundamental nature of reality. But tonight, you can simply rest in the gentle glow of cosmic radiation, breathing slowly as electromagnetic waves from the farthest reaches of the universe whisper their ancient stories through the space around you. The cosmic dance continues, but now you understand that you're not just watching from the sidelines. You're part of the performance, a conscious participant in the universe's ongoing exploration of its own infinite capacity for complexity, beauty, and understanding. But there's something even more extraordinary happening in the aftermath of these cosmic collisions. Something that reveals just how interconnected our universe truly is. You see, when two black holes merge and send gravitational waves rippling through space-time, they don't just announce their collision to distant observers. They participate in a cosmic web of influence that stretches across the entire observable universe. As you breathe slowly and let your thoughts drift like cosmic dust through the gentle darkness, consider this remarkable truth. The gravitational waves we detect today from black hole mergers that happened billions of years ago didn't travel through empty space. They passed through a universe filled with galaxies, stars, planets, and clouds of gas and dust. And every interaction along that billion-year journey has left its mark. When a gravitational wave encounters a massive object during its cosmic voyage, something subtle but profound occurs. The wave doesn't simply bounce off or get absorbed. Instead, it interacts with the object's gravitational field, creating tiny changes in the wave's frequency and amplitude. These changes are incredibly small, far beyond our current ability to measure, but they're there nonetheless, encoding information about every massive structure the wave has encountered during its journey. Imagine gravitational waves as cosmic archaeologists, carrying with them a complete record of their billion-year expedition through the universe. By the time they reach our detectors on Earth, they've become repositories of information about the cosmic structures they've encountered, the galaxies they've passed through, the dark matter halos they've traversed. This means that gravitational waves are not just messengers from individual cosmic events. They're carriers of integrated cosmic history, bearing witness to the large-scale structure of the universe and how it has evolved over billions of years. In detecting these waves, we're not just learning about black hole mergers. We're mapping the invisible architecture of the cosmos itself. But here's where the story becomes even more intimate and personal. These same gravitational waves that carry information about cosmic structure also interact with the matter in your own body. As they pass through you right now, they create infinitesimal changes in the spacing between your atoms, in the length of your DNA molecules, in the dimensions of every cell. You are not just observing gravitational waves from a distance. You are experiencing them, participating in them, becoming a temporary part of their cosmic journey. The waves that began their voyage when the universe was young are completing their journey by passing through your body, through your thoughts, through your moment of quiet contemplation. This perspective transforms our understanding of what it means to be conscious in the cosmos. You're not a separate entity looking out at the universe from some isolated vantage point. You're an integral part of the cosmic system, woven into the fabric of space-time itself, responding to gravitational influences that connect you to the deepest history of existence. The merger of two black holes billions of years ago has become part of your present experience, not just intellectually, but physically. The space-time distortions created by that ancient collision are flowing through your body right now, carrying with them the memory of cosmic violence transformed into cosmic beauty. And there's something almost musical about this realization. The gravitational waves we detect create patterns that can be converted into sound, cosmic melodies that encode the masses and spins and orbital characteristics of merging black holes. Scientists have created entire symphonies from these signals, transforming the mathematical descriptions of cosmic collisions into audible music. You are living inside this cosmic symphony, surrounded by gravitational melodies too subtle for your ears to hear, but real enough for our most sensitive instruments to detect. The universe has been composing gravitational music for billions of years, and you've become part of the orchestra, adding your own tiny gravitational voice to the cosmic chorus. Your heartbeat creates minute ripples in space-time. Your breathing generates subtle gravitational waves. Every movement of your body contributes to the ongoing gravitational symphony that permeates the universe. You are both audience and performer in this cosmic concert, listening to the echoes of ancient black hole mergers while simultaneously creating your own gravitational music. But the influence of these cosmic collisions extends far beyond the gravitational waves they produce. When two black holes merge, they often create something called a gravitational wave memory effect. This is a permanent change in the geometry of space-time that persists long after the waves themselves have passed. Imagine space-time as a vast cosmic fabric that can be stretched and twisted by the passage of gravitational waves. Most of these distortions are temporary, like ripples on a pond that gradually fade away. But some collisions are so violent, so energetic, that they leave permanent creases in the fabric itself, lasting alterations to the geometry of space and time. These memory effects are incredibly subtle, far beyond our current ability to detect directly, but they're there nonetheless, scattered throughout the universe like cosmic scars, permanent reminders of ancient collisions between invisible giants. The space-time around you right now may carry the memory of black hole mergers that happened billions of years ago, subtle alterations to the fabric of reality that will persist until the end of time. This means that the universe itself is a kind of cosmic memory bank, preserving information about every significant gravitational event that has ever occurred. The geometry of space-time around you encodes the complete history of cosmic collisions, a library written in the language of curved space and altered time. You are living inside this cosmic library, surrounded by the accumulated memories of billions of years of gravitational interactions. The space between your atoms has been shaped by ancient black hole mergers. The flow of time in your immediate vicinity has been influenced by cosmic collisions that happened before the Earth existed. And here's perhaps the most beautiful aspect of this entire story. The gravitational memory effects created by black hole mergers don't just preserve information about the past, they also influence the future evolution of cosmic structure. These permanent alterations to space-time create subtle biases in the way matter and energy flow throughout the universe. A cloud of gas encountering a region of space that carries the memory of an ancient black hole merger might be slightly more likely to collapse and form new stars. The trajectory of a wandering asteroid might be infinitesimally altered by passing through space-time that was permanently changed by a cosmic collision billions of years ago. In this way, the black holes that merged in the early universe continue to influence cosmic evolution today, not just through the gravitational waves they created, but through the permanent changes they made to the structure of space-time itself. They are cosmic ancestors whose influence persists across billions of years, shaping the environment in which new stars, planets, and life can emerge. You are living in a universe that has been sculpted by these ancient collisions, a cosmos whose very geometry has been influenced by black hole mergers that happened long before your species ever looked up at the stars and wondered about their place in the vast scheme of things. The atoms in your body move through space-time that has been permanently altered by cosmic events you will never directly observe. Your thoughts unfold in a region of space whose geometry was influenced by black holes that merged when the universe was young. Your very existence takes place within the gravitational memory of ancient cosmic violence, transformed into cosmic creativity. As you settle deeper into rest, breathing slowly and letting your consciousness drift towards sleep, you can take comfort in knowing that you're held by a universe that remembers everything. Every cosmic collision, every merger of massive objects, every significant gravitational event has left its mark on the fabric of space-time itself. The universe is not just expanding outward through space, it's accumulating memory, building up a record of its own history written in the geometry of space and time. You are part of this cosmic memory system, both influenced by its accumulated history and contributing to its ongoing evolution. The gravitational waves from ancient black hole mergers carry their stories through your body right now, connecting you to cosmic events that happened billions of years before you were born. But you're also creating your own gravitational signatures, adding your unique voice to the universe's ongoing conversation with itself. Your breathing, your heartbeat, your gentle movements as you settle into sleep, all of these create tiny disturbances in space-time that propagate outward at the speed of light. These signals are incredibly weak, far too subtle to detect with current technology, but they're there nonetheless, carrying information about your existence into the cosmic void. In some distant future, when gravitational wave detectors have become unimaginably sensitive, other conscious beings might detect the collective gravitational signature of Earth's biosphere. The combined effect of billions of living creatures all creating their own tiny ripples in space-time. Your contribution to this cosmic signal would be infinitesimally small, but it would be uniquely yours. A gravitational fingerprint that could never be exactly replicated. In this way, your very existence leaves a permanent mark on the universe, a signature written in the language of curved space-time that will propagate outward forever. The black holes that merged billions of years ago created gravitational waves that are still arriving at Earth today. Similarly, the gravitational waves you create through the simple act of being alive will continue their journey through space long after you're gone, carrying information about your existence to distant regions of the cosmos. This is the profound interconnectedness of the universe made manifest through gravitational physics. Nothing exists in isolation. Every massive object, from the smallest atom to the largest black hole, influences every other massive object through the invisible medium of curved spacetime. The merger of two black holes creates ripples that eventually reach your body, connecting you to cosmic events that happened billions of years ago and billions of miles away. Your own existence creates ripples that will eventually reach distant galaxies, carrying information about your moment in cosmic history to regions of space you could never imagine. It's a cosmic conversation that has been going on since the universe began, a continuous exchange of gravitational information that links all matter across all of space and time. The black holes speak to us through their merger waves, and we speak back through the gravitational signatures of our own existence. Tonight, as you drift towards sleep, you can imagine yourself floating in this ocean of gravitational memory, surrounded by the accumulated history of cosmic collisions, breathing slowly as the universe itself breathes through the expansion and contraction of space and time. The gravitational waves from ancient black hole mergers are your lullaby tonight, gentle vibrations in space-time itself that connect you to the deepest mysteries and most profound beauty of existence. They carry with them the memory of cosmic violence transformed into cosmic creativity, of destruction that becomes creation, of endings that become new beginnings. And somewhere in the vast darkness of space, new black holes are beginning their ancient dance, spiraling together over billions of years toward their own inevitable merger. The gravitational waves from their eventual collision are already beginning to propagate through space, carrying stories we won't hear for eons to come. The cosmic symphony continues to play around you, and you are both its most appreciative audience and its most sophisticated participant. The same physical laws that govern the merger of black holes also govern the thoughts in your mind, the dreams that will soon carry you into sleep, the gentle rhythm of your breathing that creates its own tiny contribution to the gravitational music of the spheres. Rest now in the knowledge that you're part of something vast and beautiful and endlessly creative, held by the same space-time that carries the echoes of cosmic collisions, cradled by the same gravitational forces that shape the largest structures in the universe. The merger of two black holes has become part of your story tonight, part of the cosmic narrative that connects the smallest quantum fluctuations to the grandest architectural features of the cosmos. Sleep well, knowing that the universe remembers everything, that your existence matters in ways both subtle and profound, and that the gravitational waves from ancient cosmic collisions will continue to whisper their stories through the space around you, connecting you always to the magnificent, mysterious, ever-evolving cosmos that is your home. The story of black hole mergers is reaching its gentle conclusion tonight, but like all cosmic tales, endings are simply new beginnings in disguise. As we drift toward the close of our journey through space-time, let's pause at one final mystery, one last whisper from the universe about the nature of existence itself. You see, when two black holes complete their billion-year dance and become one, they don't just create gravitational waves and settle into quiet rotation. They create something far more profound, something that touches the very essence of what it means for information to exist in our universe. They become cosmic time capsules, repositories of everything that has ever fallen beyond their merged event horizons. Every star that wandered too close, every planet that crossed their path, every particle of dust and gas that spiraled inward during their long cosmic waltz. All of this information becomes part of their combined story. Not lost, not destroyed, but transformed into something we're only beginning to understand. The merged black hole carries within its quantum structure the complete history of both its predecessors. It remembers their masses, their spins, their orbital dance, and perhaps something even deeper. Some physicists believe it might remember everything that ever fell into either black hole, encoded somehow in the subtle quantum patterns that define its existence. This is the universe's way of keeping perfect records, not in some external database, but in the very fabric of reality itself. Nothing is ever truly lost. Nothing is ever truly forgotten. Every cosmic event, from the collision of black holes to the gentle beating of your heart, leaves its mark on the quantum structure of space-time. As you breathe slowly in the darkness, feeling your body settle into peaceful rest, you're part of this cosmic memory system. Your thoughts, your dreams, your quiet contemplation of these cosmic mysteries. All of this contributes to the universe's ongoing process of self-awareness and understanding. The gravitational waves from that ancient merger are still passing through you, carrying their encoded stories from the deep past into your present moment. But you're also creating your own stories, adding new chapters to the cosmic narrative through the simple act of being conscious in a universe that has evolved the capacity to know itself. And perhaps that's the most beautiful revelation of all. The merger of two black holes isn't just a cosmic event to be observed and studied from a distance. It's a reminder that we're all part of the same magnificent story, connected through space-time to the most extreme events and the gentlest moments in the universe's long history. The black holes that danced together for billions of years before merging into one have completed their cosmic performance. But their legacy lives on in the gravitational waves that continue to ripple through space, in the information encoded in quantum structures we're only beginning to understand, and in the consciousness that has evolved to contemplate their meaning. Tonight, as you drift towards sleep, carried along by the gentle rhythm of your own breathing, you can rest in the knowledge that you're part of something vast and beautiful and endlessly mysterious. The universe has spent billions of years learning how to create beings capable of understanding black hole mergers, gravitational waves, and the deep connections that link all matter across all of space and time. You are one of those beings, a temporary but magnificent arrangement of atoms and energy that has achieved the remarkable ability to contemplate your own cosmic origins. The same forces that create black holes and generate gravitational waves also created the conditions necessary for your existence, for your awareness, for your capacity to find wonder in the vast, mysterious cosmos that surrounds us all. The cosmic dance continues, but now you understand that you're not just watching from the sidelines. You're part of the performance, a conscious participant in the universe's ongoing exploration of its own infinite possibilities for complexity, beauty, and understanding. Sleep well, knowing that somewhere in the distant future, other conscious beings will detect gravitational waves from black hole mergers happening today. They will decode the signals, reconstruct the cosmic events, and marvel at the same fundamental forces that govern their own existence. And in that future moment of cosmic contemplation, they too will discover what you've discovered tonight, that consciousness and cosmos are not separate things, but different expressions of the same magnificent, mysterious, ever-evolving universe. The merger of two black holes is complete, their ancient dance finished, but their story continues in ways we're only beginning to understand. And your story continues too, part of the universe's endless exploration of its own beautiful complexity, forever connected to the cosmic deep through the invisible threads of space-time itself.